So the binary coded system uses a 4-bit code to represent every digit. This 4 bits code phenomena I introduced in hexadecimal. I said that the hexadecimal's largest digit is 15, and 15 can be accommodated in 4 bits. So a byte can accommodate 2 uh, hexadecimal digits. Since 15 can be accommodated in 4 bits, so every digit of hexadecimal from 0 to 15 can be accommodated in 4 bits. This is what we studied, this is what we practiced. That 4-bit phenomena is applied to binary coded decimal, but since it is not hexadecimal, it is simply decimal. It means that the digit that we are going to deal with are just denary. I told you that denary and decimal are actually synonyms, they are the same. So denary number system or decimal number system, they are the same. So they have digits from 0 to 9, no more than that. After 9, the 10 comes up in counting, but that is made with 1 and 0. So unique, different digits or shapes are just from 0 to 9. So we have got 4 spaces, 4 bits to represent every digit in binary coded decimal. So we have got 0, we have got 1, 2, 3, 4, 5, 6, 7, 8, and 9. And we have got 4 bits. 1, 2, 4, and 8. Alright, so 0 would be this, 1 would be this, 2 would be this is 3, this is 4, this is 5, this is 6, 7, 8, and 9. ठीक है बेटा, ये जब भी हम किसी नंबर को BCD में कन्वर्ट करते हैं तो हम क्या करते हैं, उसके हर डिजिट को उसके इक्वल 4 बिट्स में डिवाइड कर देते हैं. और we have to complete the byte because the least amount of data that a computer can save is a byte. What does it mean? Let's see. Let's say I have got a number 3165 and I am asked to convert this number to its BCD form, binary coded decimal form. So what I would do, I will take 3, I'll make 3, I'll take 1, I'll make 1, then 6, then 6, and then 5, then 5. All right, so this would become 3, 1, 6, and 5. 0, 1, 0, 1. This is BCD. Simply, this is BCD. That's it. This is called BCD. So whenever you are asked to convert a number to its equivalent BCD, all you have to do is to take every digit, find its 4 digits, equivalent BCD, which is not hard because that is ordinary 1, 2, 4, 8 thing, and then put them alongside each other. And that's about it. That is BCD. But you might have a situation where it says, let's say for 2 digits, let's say for 1 digit, they ask you to make BCD for 9. तो आप कैसे बनाओगे? 1, 2, 4, 8. This is 9. 1, 2, 4, and 8. This is 9. But We cannot save it. We have to complete the byte. So you will be putting like 4 bits more. You have to complete the byte. What does it mean? It means if you get any number with odd number of digits, so you would have to put a left on the most significant side to complete the byte. Let's say you are asked for 23. That is easy. 2 on the left, 3 on the right. That is 23. Perfect. But what if you are asked to complete 124? So that you will be like 1, 2, and 4. But this is 1.5 byte. So this is odd number of digits in this number. So you would have to put a 0 there. Or if you don't put a 0 in the binary form, but put the 0 in binary form to complete the byte, because हम 1.5 byte, पौने 2 bytes, आधा byte, 3.5 byte save नहीं कर सकते. We have to complete the byte. Since computer cannot save a byte, at least saves a byte, cannot save a half byte. So you have to put a 0 on the left so that you complete a byte. So this is 1 byte, this is another 1 byte. Okay, get the idea. So this is one thing. Another thing that may come up would be, they may ask you to 0010, 0011, 1000, and 0111. And they ask you, okay, which number is this in denary form? So you will be like, this is 7, this is 8, this is 3, this is 2. So this is 2, 3, 8, 7 in denary. That is fine, super. But know one thing, which is actually dangerous. What is the range? For 4 bits, the range is 16, means 0 to 15. And we have got how many digits? 0 to 9. What is the count? 10. So this 15 and this 10 has a difference. All right. And what is that difference? The largest number that you can create in 4 bits is 15. All right. And what is the largest number in denary? That is 9. So there is a difference. This difference is termed as error. And this error may show up at many locations. All right, this error may show up at many locations. For example, at least on the least side, you might be given a number 00101011, and you are asked to convert this number to its equivalent denary. So you'll be like, this is 2, this is 1, 2, 4, 8. 8 and 2, 10 and 1, 11. 11 cannot be the BCD because the highest number that you may have would be 9. Only 9. BCD is D, decimal, denary. So you cannot have any single digit in 4 bits greater than 9. But when you perform calculations or you are given BCD form and you are asked to convert to denary, you may have situations. So this number is not a BCD. This is not a BCD number. This is not a BCD. Had that been in BCD form, these figures should be from 0 to 9, not more than that. Okay, so you have to keep that in your mind with it. All right, so this is a common practice that you are given a BCD form number and you are asked to convert it to denary, but when you convert the number, you see that the number is beyond 9 and that is in this error area, means this is either 10, 11, 12, 13, 14 or 15. All right, so that you cannot actually accommodate. This was one thing. So now uses of BCD. Uses of BCD. This is actually a common question. Uses of BCD. Where do we use BCD? Uses of BCD. The most obvious use of BCD is in the representation of digits on a calculator or a clock display. All right, so in calculators and clock displays, something like this. This is 8, this is 2. So such type of displays, they actually make use of what? BCD, to show the numbers and to store the numbers. All right, such type of displays. This is 7-segment display. The name is 7-segment display. All right. So the most obvious use of BCD is in the representation of digits on a calculator or a clock display. Each denary digit will have a BCD equivalent value, which makes it easy to convert from computer output to denary display. That is very easy. Now, we will learn next year that it is nearly impossible to represent decimal values exactly in computer memories. We will learn about it. So in that case, sometimes we have to actually use BCD. What is that? How that would work? That is in A2. Let's find. This is now whatever that I'm going to do is BCD calculation, BCD addition. But this is just for the purpose of understanding of errors in BCD. This might not appear in exam. All right. So syllabus reference to it, but syllabus does not actually enforce it. So do not think that whatever that we are now going to study is part of the syllabus. This is just for your reference to understand this error. So let's say you have to add 27 to 38. All right, in BCD form. So how do we come up with 2? This is 2. All right, and this is 7. This is 27, and then 38. This is 3, and this is 8. Let's add them. So we have to put every single BCD beneath another BCD, and then we will add digit by digit. Okay. So 1 plus 0, 1, 1 plus 0, 1, 1 plus 0, 1, 1 plus 0 plus 1, 1. 0 plus 1, 1, 1 plus 1, 2, 1 carry 1 and 0. So what are we expecting over here? We are expecting that answer would be 5, 1 carry and 6, 65. We are expecting 65. We are expecting what? 65. And what is the answer over here? This is 1, 2, 4, 5, and this is all 15. There is an error. So how do we actually overcome this error situation in BCD? We have to complete this calculation. So what we will do, we will take this answer 0, 1, 0, 1 and 1, 1, 1 and 1. And to the BCD which has an error, this does not have an error. This is 5 that can be represented, but this is 15. This cannot be represented. Remember what was error? 6. We will add that 6 to this. 6 to this. So this is 6. 4 and 2, 6. We will add this to the byte that has an error. Half byte, nibble, sorry. 1 plus 0, 0, sorry, 1. 1 plus 0, 1. 1 plus 1, 2. that makes it 3, and that is 0. So what is answer? 101. Now the carry from this addition, so 1 plus 1, 2, 0 sum and 1 carry. This will come over here, 2, 1 carry, and then 1 and 0. So we added what? We actually added error. And what was error? 6 to the BCD, which was actually incorrect. 15 was incorrect, so we added 6 to it. Now check the answer. After adding, this is 101, which is 5. 1, 2, 4. 4 plus 1, 5. And what is this? 6. Do you see what we are expecting over here? So this is 65. You might not be asked to add numbers and all. So I just wanted to tell you that having this ability to save a digit which is beyond 9 and up to 15 will always bring you to the point that you might come across a BCD digit as an answer of an arithmetic operation which is not BCD at all. So to that part of the BCD, we will add error. Error is referred to as 6. So we will add 6. So once we add 6, resultant would be definitely correct. All right. So this is what I wanted to tell you. Let's just discuss the syllabus so that we have an idea that how much have we covered yet. Lisa, 6 is like the limit of accuracy. 6 is like the limit of accuracy. I call 6 error. If there are errors, then we will add the binary equivalent of 6 to the first block of bits. Not to the first, in this case, yes, to the first block of bits. Any block, any 4 bits of denary which has this error, we will add 6 to it. All right. Not just to the right block or left block. It might be like we have got 3 digits, let's say 3, 7, 5 and 128. We are going to add these 3. First of all, the BCD के अंदर हमारे साथ मुसीबत ये होगी कि हम इनको बना नहीं सकेंगे, तो हम क्या करेंगे कि हम यहाँ पर लगाएंगे 0. सही है, 0, 128 and 0, 375. So 0, 0, 0, 0, 0, 0, 1, 1, 0, 1, 1, 1, 0, 1, 0, 1. ये हो गया 375 and 0, 1, 2 and 8. This is 4 bits now. Let's add all of them. So what we are expecting 8 and 5, 13, 7 and 1, 8 and 9 and 10, 3 and 1, 4 and 5. Yes, 503. This is what we are expecting. Let's see. From always perform calculations from right to left. All right. So 1 plus 0, 1, 0 plus 0, 0, 1 plus 0, 1, 0 plus 1, 1, error. 0, 1 plus 0, 1, 1 plus 1, 2, 1 plus 1, 2. There is no error. This is 9. 1 plus 0, 1, 1 plus 1, 2, 0, 1, 1 plus 1, 2, 0, 1 and 1. 1 plus 1, 2, 1 carry, 1 plus 1, 2, 1 carry, no error. And then we have got all zeros here. So we only have error over here, so we will add 6 over here. All right, so 1 plus 0, 1, 0 plus 1, 1, 1 plus 1, 2, 1 plus 1, 2, so 1 plus 1, 2, and then we have got 0 and 1. This has introduced another error. Okay, so 1 plus 0, 1, 0 plus 1, 1, 1 plus 1, 2, 1 carry, 1 plus 1, 2, 1 carry, 1 plus 1, 2, 1 carry, 1 plus 0, 1, 0 and 1. Now see, this is now correct, this is incorrect. So we will, 1, why it is incorrect? Because this is 1 and 8, 10. This is incorrect. So what we do now, we add 6 to it. So 0 plus 0, 0, 1 plus 1, 2, 1 carry, 1 plus 1, 2, 1 carry, 1 plus 1, 2, 1 carry. So 1 plus 1, 1 plus 1, 2, 0 and 1 carry. And we will take this one over here. 1, 0, 1, 0 and then 0, 0, 0, 0. All right. So let's just copy it down. This is 1, 1, 0, 0. So this is 3. This is 0. This is 5. This is 0. Exactly what we were expecting. So this error thing may go to any level. I deliberately chosen this question because of the Aliza's questions, in response of Aliza's question, that it is not always on the right, sometimes it is in the middle. So whatever the digit that is not having BCD up to 9, we have to add 6. So yeah, so in this case we added over here, in this case we added over here. All right, so we have to keep adding 6, 6, 6, 6 to the point that all BCD digits are what we were expecting, means 0 to 9. All right, so let's discuss the syllabus. अब देखिए हमने कितना कवर किया है. Candidates should be able to show understanding of binary magnitude and the difference between binary prefixes and decimal prefixes. So notes and guides, understand the difference between, to achieve this you have to achieve this. All right, understand the difference between kibi and kilo, MIBI and mega, GB and giga, and TB and tera. So you got it now. Okay, I'm going to send you these images of the pages which I have just written. So you would have this understanding and you have to keep it in mind. Show understanding of the basis of different number system. Use the binary, denary, hexa, decimal number basis and BCD and ones and twos complement representation of binary numbers. We have covered all these.